Hello students, in this section and in this video we're going to discuss the introduction to normal distributions and the standard normal distribution. So you may remember in the previous chapter we talked about probability distributions in general, including discrete distributions. So one of the discrete probability distributions we talked about was the binomial distribution. So in this chapter, we're going to talk about a continuous probability distribution called the normal distribution. Okay, so it's one of the most important distributions in statistics. So normal distributions can be used to model many sets of measurements in nature, industry, and business. So for instance, the systolic blood pressures of humans, the lifetimes of smartphones, and housing costs are all normally distributed random variables. Okay, so on the definition on page 234, I talked about different properties of the normal distribution, and you can read about these on your own. But this is what the graph of a typical normal distribution looks like. It's got the bell-shaped, and it's symmetric. So in this section, we're going to focus on what's called the standard normal distribution. So the standard normal distribution has a mean of 0 and a standard deviation of 1. So in symbols, right, mu is equal to 0 and sigma is equal to 1. So mu represents the mean, and then sigma is the standard deviation. So any other normal distribution has a mean not equal to 0 or standard deviation not equal to 1. So for any other normal distribution, right, either mu is equal to 0 or sigma is not equal to 1, or both. So in this section, you will be asked to find areas or probabilities inside the standard normal curve. And then later in the chapter, you will find areas or probabilities inside other normal curves. So the methods you learned in this section will be used throughout the chapter. Okay, so one of the important properties to realize about the normal curve is that the total area inside the curve is equal to 1. So remember, the normal curve or normal distribution is a probability distribution. Okay, so the total area inside the curve from negative infinity to positive infinity is going to be 1. And then the mean of the curve is in the middle. And the standard deviation affects the width of the curve. And you can read more about this in the section. Okay, so you can see that for different values of the standard deviation sigma, it affects how the curve looks, specifically the spread of the curve. So the standard deviation affects the spread of the curve, and then likewise the mean affects the location of the curve. Right, so the mean always occurs at the peak. So for different values of the mean, right, the peak of the curve will be in different locations. Right, you can see that with example 1 on page 235. Okay, so let's talk briefly about the standard normal distribution. Okay, so remember, the normal distribution with the mean of 0 and standard deviation of 1 is called the standard normal distribution. So it's important to know that. So for any standard normal distribution, the mean is always going to be 0, and the standard deviation is always going to be equal to 1. Okay, just like with any normal distribution, the total area inside the curve is 1, and then the values you see on the horizontal axis are called z-scores. So let's go ahead and take a look at the homework. Okay, so question 1 asks you what the total area under the curve is, so you can answer that right away. Okay, question 2 asks what requirements are necessary for a normal probability distribution to be a standard normal distribution. So we've already discussed that, so you would select the appropriate answer choice for number 2. Okay, so what we're going to focus on is answering questions like number 3 here. So the question says, find the area of the shaded region. So you have a standard normal curve and a given z-score. In this case, the z-score is 0.63. So the graph depicts the standard normal distribution with a mean of 0 and standard deviation of 1. Okay, so we're finding the area inside the curve to the left of z equal to 0.63. So we're going to go ahead and use the normal distribution calculator in StatCrunch. So we're going to go to the Stat menu, Calculators, and select Normal. Alright, and since we're working with the standard normal distribution, the mean is always going to be 0, and the standard deviation is 1, so we're not going to change those. And we want to find the area to the left of z equal to 0.63. So in our calculators, we're going to make sure we have the appropriate symbol selected, so the less than or equal to symbol. And then we're going to type in the z-score of 0.63, so that the value that we're given goes here in this box. Okay, so even though this says x, right, when the mean is 0, standard deviation of 1, it's understood that for the standard normal distribution, we are working with z-scores. So we're not going to worry about the x here. So you can pretend there's a z here, so z less than or equal to 0.63, and when we click compute, the area is going to appear in this box here. Okay, so depending on the problem, you're going to round your probability to 3 or 4 decimal places. We want 4 decimal places in our answer, so it's 4 digits after the decimal point. Okay, so make sure you round appropriately, so that 6 there will get rounded up to a 7, so that the 6 is in the rounding position. So if it's 5 or more, let it soar, so it becomes 0.7357. Okay, so the area inside the standard normal curve to the left of 0.63 is that number there, 0.7357. Okay, so now we're going to find the area of the shaded region under the normal curve. In this case, it's the region in blue that we're finding. And you can see that the shaded region is to the right of the given z-score of 1.51. Okay, so don't worry about the table. We're not going to use the table to answer these questions. We're always going to use the calculator in StatCrunch. Okay, so we want to find the area to the right of z equal to 1.51 inside the standard normal curve. Okay, the mean and standard deviation are still 0 and 1. Because we're finding an area to the right, we're going to select the greater than or equal to symbol. Okay, and then type in the z-score in this box here. And then click compute. Okay, so that area to the right, which you can see is shaded in red here, to 4 decimal places is 0.0655. Okay, so now we're going to find the area of the indicated region under the standard normal curve. Okay, that's between these two values. Okay, so we're still dealing with z-scores. Okay, so we have negative 1.2 and 1.1. So we have the area between those two z-scores inside the normal curve. Alright, so the area between z equal to negative 1.2 and z equal to 1.1 under the normal curve is blank. So to find an area between two values with the normal calculator, we're going to select between. Okay, and the mean of 0, standard deviation of 1 is still the same. Okay, so negative 1.2 goes on the left, 1.1 goes on the right. So negative 1.2 goes here, 1.1 goes here. Alright, so the area between these two values in the standard normal curve, okay, we round it to 4 decimal places, it's 0.7493. So that 2 there gets rounded up to a 3, so 0.7493. Okay, so in the next few questions, you don't have a nice picture to work with, but it tells you the z-score and whether you're finding the area to the left, to the right, or between two values. Okay, so the directions say to find the indicated area under the standard normal curve. Okay, so remember the standard normal curve has a mean of 0, standard deviation of 1. This is our z-score. So for number 6, right, to the left of z equal to negative 0.35, we're going to go back to standard. Okay, mean of 0, standard deviation of 1 is unchanged. Because we want the area to the left, we're going to select the less than or equal to symbol. So the reason is that that symbol points toward the left. Okay, so we're going to type in the z-score here, so negative 1.35. Alright, and the area to the left is that number there. I apologize, it should be negative 0.35, not negative 1.35. So I gotta revise that, so negative 0.35. Okay, so the area is this number here, so 0.3631. And again, be careful how you round it. So we can type in 0.3631 and see if it accepts it. So 0.3631. Okay, so again, you might have the correct answer, right? But you might not be rounding it properly. So rounding really does matter. Okay, so that 1 there will get rounded up to a 2 because the number to its right is 5 or more, let it soar, so it's 0.3632. Guess we're going to change that 1 to a 2. And we have the correct answer. Okay, so let's try one more. Let's find the indicated area under the standard normal curve to the right of z equal to 2.49. Okay, so going back to our normal calculator, we're going to now select the greater than or equal to symbol, type in the corresponding z-score, 2.49, and then click compute to get that area to the right, okay, which is shaded in red here. Okay, so the 4 decimal places, it would be 0.0063, but that 3 will get rounded up to a 4, so 0.0064 is the answer. Okay, so I'm going to go ahead and skip number 8. So number 8 is asking me to find the area between those two z-scores, just like what we talked about before. To find an area between two values, in the normal calculator, select between, right, type in the mean and standard deviation. In this case, there's still going to be 0 and 1, and then type in the two values here, and then click compute. So I'm going to go ahead and skip over number 8. Okay, and that was it. So there are no other questions, so that completes this section on the standard normal distribution. Thank you for watching.